Awards. Very excited to have her here today. And with that, Jyoti, let's turn it over to you.
Thank you so much. I'm really excited to be here. And hello, everyone. Welcome to the session. Uh, and I'll be discussing the basics of AI and how it affects the UX decisions in general. I will try to explain things in the simplest way possible and in the process avoid buzzwords or complicated terminology in general. However, please don't hesitate to ask any questions if you need any further clarifications. So let's begin. Okay, perfect. So I'm sure no one in the audience would be new to the term artificial intelligence or AI. But the question what that we want to answer today is why should we be concerned about the designers we may work with or on how we design a solution if there are any designers who are listening to the session and how designing an AI solution is different from a non-AI solution. Or rather, let's just say, why do AI engineers need the support of designers to build a better user experience to complement the technology? To find the answers to these questions, let's delve a bit deeper into AI. Now, before we answer what AI is, let's first see what intelligence means. The dictionary definition of intelligence says that intelligence is the ability to learn, understand, or to deal with new or trying situation, or the ability to apply knowledge to manipulate one's environment, or to think abstractly as measured by objective criteria. Now, if we break down this definition into granular aspects, we can summarize the primary drivers of intelligence into learning, understanding, and reasoning. This makes humans solve problems and think rationally. As we know that these basic abilities can be different for different people, and there can be a lot of nuances to consider when we say human intelligence. So let's just keep things simple, and for the purposes of this talk, consider the use of the term human intelligence as a cover term for collective human intelligence. Okay, so coming back to artificial intelligence, it refers to building a machine which is as intelligent as an expert on almost all the tasks and can even overpower human capabilities. Intelligence itself can be quite subjective, and we will discuss it in more details in a minute. But here, if you see on the right hand side on the slide, the bottom right represents this goal. However, the current state of AI is far, far away from that goal, and we use intelligent agents that do very specific tasks intelligently. A few examples could be recommendations or sentiment analysis or image classification, and so on and so forth. These are a very few examples of very specific problem statements that are being solved using AI technology today. This state is represented as narrow AI in the middle. And as we are far, far away from a perfect AI, there are a lot of things that we need to consider while making UX decisions. And thus, there is a need of understanding the effects of design. So, what does artificial intelligence mean? You would probably be aware of a lot of buzzwords around AI, like machine learning, deep learning, data science, models, recommendation engines, big data, chatbot, so on and so forth. Like there are a huge amount of terms and buzzwords available. It is really easy to get lost in all these buzzwords and lose sight of what is important. And hence, let's go through this step by step and make some sense of a few basic terms used in AI technology and how they impact design decisions. So for this presentation, I will not be going very deep into the topics around the production, pipeline essentials, etc. in the interest of time, and stick only to the details that the design aspect requires. But if you have any questions, please feel free to type them up in the chat. Also, I'm assuming that a lot of audience here would already be aware of machine learning in general, or probably would have attended similar sessions in this conference. So please excuse me if you feel like it's repetitive. Okay, so let's go back to the basics. How do the machines think? Or more specifically, what is the language that computers understand? So we are all hopefully coders here, or maybe not. So I excuse me for that. And I guess most of you would already be aware of how the hierarchy between machines and humans in terms of language works. Usually we communicate with the machines using a user interface or codes or scripts or sometimes even numbers or bits, specifically when hardware comes into picture. So these are all kind of technical artifacts that are used. So when we say intelligent machines, there can be a lot of ways that these three components can be bundled together to seem intelligent. However, the source of this intelligence plays a big role when considering the design, and it also affects whether the solution really is AI-based or just an automation. This bundling is the thing that we need to break down further and have a detailed information on how to design a successful product. Now let's go back to the building blocks of intelligence and apply the same here. We had learning, understanding, and reasoning that are the basic building blocks. So, however, intelligence is judged on the basis of an outcome. If the outcome seems smart, it could be assumed as an AI. But here is where lies a crucial differentiator, which is very important to understand while designing AI solutions. The question to ask here is, if a solution seems smart, there must be some kind of learning involved. But who is a learner here? Is it a machine or is it a human converting their knowledge into technical artifacts? Similarly, who is the one understanding and reasoning? Smartness can be scripted by the person writing the script. For example, a product which is developed by a team which has domain expertise and good technical knowledge with all possible edge cases can seem very smart. The differentiator is to understand if this encoded knowledge inside the product is encoded by a human in terms of some sort of procedural steps to be taken while running the code, or is it encoded by the machine itself in some form? So let's consider an example. Here are two chat windows, and let's assume both of them are chatbots. Take a few seconds and notice how they are different. So in both the windows, the request is somehow very similar, assuming that the user wants to open an account in both the scenarios. However, in the first scenario, the user is guided through a procedure already built in by this into the system and enforcing something like an if else statement. In the second window, though, it seems that the bot decides or listens to the user input and makes a decision automatically that opening an account should probably mean banking services. Hence, the first chat window represents automation, and the second could probably be AI, but we are not sure. Even though it seems smarter, we cannot certainly say that it is AI. So, why? Let's consider another example. So, the first window here is the one we saw earlier on the right hand side. However, notice the second window. As I mentioned in the previous slide, the first window here could be an AI, but we are not sure. But the second window represents a much higher possibility of a truly smart behavior and can be considered as an AI. Now, what could be the reason behind this rationale? Because to most of the people, these two may seem quite the same thing. The reason for that is if a smart coder is developing this bot, they can easily use some kind of if-else statement or template which decides that if words like open account is present in the user request, it could certainly mean that the user wants to access the banking services and hence redirects the flow accordingly using a script. Now, this could seem like a simple logic that can be coded coded basically. In the second case, though, it is highly unlikely that this would be included as a template to make decisions because the words used here do not appear that often in such requests and thus would be hard to encode in a script. Hence, we can assume that there is a great AI model at the backend which is classifying the sentences on the go for us without any pre-existing templates. An important point to consider is that chatbot solutions are usually a combination of automation, that is pre-existing templates, and AI. And this is why designing dialogues must be considered at the most granular level possible. So I'm taking an example of the chatbot because that's much more famous these days and everyone is building one. But there are many other solutions that work in the similar way. Now let's see how AI works in terms of the building blocks and how design can have an impact. So coming back to the slide, let's discuss how AI works behind the scenes. For any system to be intelligent, we have already established that it requires learning, understanding, and reasoning. As we discussed in the previous example, these aspects can be either encoded using a pre-existing template or can let a machine act and make the decisions themselves. So again, revisiting our earlier discussion, how can the machine learn, understand, and reason without human guidance? So the answer lies in numbers, as most of us would know. So this is what machines understands and acts on. Now the question arises, how can you represent all the knowledge and information and reasoning in the form of numbers? So most of us are aware of learning process in general. Let us consider a small child. The child has various senses which record sensations and try to make some sense of those sensations, and over a period of time, based on these learning experiences, start understanding things better and then reasoning on the basis of developed understanding. This process is very similar for all humans in general. So if we take this analogy and apply this to machine, the sensations here are mostly represented by data inputs. But for the machine to make sense out of this data, it needs to be converted into some kind of numeric data that the machine can use and process. So what is a $1 million question in the field of AI? It is how to teach machines using only numbers. Just so that you know, this is an active research area, and we are far, far away from having a perfect answer to this. Having said that, let's see an overview of how this works today. We use linear algebra and primarily vectors of some dimensions to encode information that the machine can learn from and understand. And then, based on these vectors, learn a function that can give results based on the task at hand. It all depends on the problem that we are solving. As the first step, what we try to do here is to convert any type of data into a vector representation. This can be text, images, numbers itself, video, audio, medical data, and so on and so forth. This is also an active area of research of coming up with algorithms that can accurately represent the information efficiently in vectors, which is called representation learning. So once the data is converted to a vector, how does the machine learn a specific task? Now, this task could be something like prediction of a price of a flat given its area, or prediction of a sentiment given a text, etc., etc. In very simple terms, let's say you give an input x to the machine and want an output y. There should be a function fx, which is usually a approximate function rather than an absolute one, that tries to calculate the y is equal to fx function. You would ask, how do you define fx? So that's machine learning. The process of estimation of fx given xy coordinates is a very basic example of how machine learning works. And while we run the process of estimation, we say that we are training a model. If you see the image on the right, you can see one simple example that anyone who has ever been introduced to machine learning would be well aware of. This is linear regression algorithm, where the red dots are xy coordinates and the blue line is estimated function fx. The black small lines represent the errors. Only in real world problems, the x dimension can be very high dimensional vector instead of a single number, and fx could be any function possible, and this is what makes the process difficult. The constants in this example, a and b, in the image are usually termed as weights and biases and saved in a file. And this file is what we call as a model or a machine learning model. So these are usually large matrices in general. The ML scenario represented here is when you have both x and y present to train models, and this is supervised learning. In a lot of tasks, you may not have y, and the algorithms used in that scenario are actually called unsupervised or probably reinforcement or many other different ways. There are several other methods which probably we cannot go deep into for now, but yeah. So as I mentioned earlier, as these vector representations are not perfect, it is highly likely that the AI product will make mistakes. These mistakes affect user experiences, and thus the design comes into picture. There are several steps that can be taken by the designers to develop a product which instills confidence in the users, even after making such mistakes. Before we start discussing the design aspects, let's understand how the AI engineers know if a model is good enough to be used. This is where evaluation of a model comes into picture. There is a norm of splitting up the data points into training data and test data, and sometimes evaluation and dev data. So this data set is used in algorithms like cross-validation, etc. And you have, probably some of you have definitely heard that term. The test data should be unseen by the model while training. Only after the training is done, the X in the test data is given as input and the model spits out a predicted Y. This Y is then compared against the actual Y, which gives us evaluation results to see how the trained model performs. The evaluation matrix itself has its own rationale behind its selection that considers different aspects like bias, variance, accuracy. Also, if you notice the ratio between the different data splits, you can notice that the higher chunk is used as training and smaller chunks as test and eval. Okay, so now keeping in mind how AI works on a very basic level, let's move to the core topic for discussion that we are here for. How does this affect the designers? How can designers get creative to mitigate the risks associated with how AI works today and take special care? Why should the designers be concerned, and how designing an AI solution is actually different than a non-AI solution? Or rather, let's just say, why do AI engineers need the support of designers to build a product which has much better user experience to complement its technology? Please note that our discussion is not about how AI can help design, but the other way around. There are a lot of AI solutions for design specifically, but that discussion is separate from the one we are having today. So let's find the answers to these questions. First and foremost thing that needs to be considered when one performs the UX research is, do you really need AI? Does AI solve any problem in particular for the end user? My guess would be that while starting to build a product, the best thing would be to not have AI in the beginning, except of course in situations where AI is the product and a lot of other scenarios like you use some pre-trained models, unsupervised learning, etc., etc. It would be much easier to debug and the experience will have a certainty attached with it. I know I'm hurting my job prospects here, but I have seen a lot of companies making such mistakes while trying to ride the AI bandwagon, which has its own financial cost attached to it, and it's very easy to underestimate the costs associated with an AI product. The other crucial thing is that AI should work for people, else it is not useful. This mostly applies to building products. The first rule of design is that the user, not the technology, is at the center of any product. Technology is to help improve the UX. Do not build an AI feature just because it's cool. The building blocks of a successful user design is context, interaction, trust, and hence important to keep that in mind. Understanding the expectations of the users and their expertise is a key point, and this applies to any solution, be it AI or non AI. One of the key things to understand would be how to handle the evaluation of the predicted results. For example, doctors using an AI system would be more interested in the fact that the diagnosis doesn't miss a likely disease and wouldn't mind a few cases where the cases turn out to be a false positive. Hence, they would be more interested in high recall. However, this would be quite opposite to what stockbroker would want from the solution. They would be ready to miss an opportunity, but wouldn't want to have a prediction with, so probably not a prediction with which fails. So some systems, this requires high precision. Some systems might not specifically be interested in them separately, but a combination of both. So F1 comes into picture. So aligning the evaluation metrics is a key aspect. Another detail to consider here is whether an AI solution is helping the user or the company itself, which is building it. I'm hoping a lot of you would have watched Social Dilemma and you would know what I'm talking about. But just to highlight to others who haven't, a lot of AI based recommendation systems work on a faulty assumption that the user who watch or visit certain media would prefer other similar media. Other similar media is the highlight. Yes, they might be money making machine, but are they ethical? So this things brings me to the next point. Ethics and privacy are emerging areas of interest, specifically in the era of data driven smart products. UX has immense power to manipulate users towards the direction of company profit. Hence, as creators, it would be a responsible and ethical behavior to consider these aspects while designing a product. We will touch upon this again in coming slides, but before that, let's now assume that you went through these decisions and finally decided to go with an AI feature in your product. The next step should be to scope out AI and non AI content in the product that needs to be designed. This will require a great amount of collaboration between the teams. A product can either be an AI product or include smaller AI components inside a complete product. For example, in the chatbot, there could be specific questions which may use AI to give some kind of results, but the rest of them could be a simple template. Hence, while designing, the awareness around every component is required. For example, while designing a conversational interface like a chatbot, the first helpful step could be to build the dialogue flow and then dive into the details around which parts of this dialogue flow would be using AI components and then move from there. As a next step, as we now understand AI models are not 100% reliable, we need to communicate the usage of AI to the user and have a clear visual separation in the design which represents AI content and non AI content. If you see the example on the right here, it is a Twitter window with a small magic diamond. When you click on it, it shows you either of the two child windows depending on your settings. You can either select the settings to see the tweets on the basis of its recency, which is demonstrated by a small clock, or you can see them on the basis of some top tweets that is decided by Twitter using some kind of smart algorithm. This is demonstrated by a magic diamond and thus helps to visually separate AI versus non AI. It is important to set the right expectations while onboarding the user and demonstrate the capabilities explicitly to build trust with the user. A little magic diamond serves a purpose here without taking up a lot of real estate. Here are a few more examples. In the first image, the satisfaction prediction is demonstrated on a scale which signifies that this is a prediction about how much the users are satisfied given the text under subject. In the second image, you can see little light knit circles which demonstrate that it is a prediction of the sentiment of that particular aspect in the overall comment, and green shows positive and red shows negative. In the third one, you see a little magic wand with the word predict, which demonstrates that it is an AI feature. A famous idea is to use confidence scores while showing the prediction results to the user, but this has to be carefully followed. A lot many times this can backfire if the model is not good enough and is very confident on incorrect predictions. Hence, this is a tip which must be used with caution, even though it appears on almost all the articles I have seen so far. While designing, it could also be helpful to give the users a freedom to choose whether or not they want to enable those AI predictions. If activated by default, inform the user about it and also consider designing the situation if the user rejects AI based content. This may not be always possible, though, so proper onboarding and expectation setting should be valuable. Moving on, together with the demonstration of AI content, it would be useful also to present an explanation of the results that the user get. This is an area of explainable AI research, and it is a step towards building trust. There are different explanations across different algorithmic usage, and the solution should be decided on the case-by-case basis. For example, a lot of recommendation engines like Amazon, Netflix, Google News have a UI which give you recommendations, and along with that, there is a small enhancement that is quite recent, and now the norm to also mention why you get those recommendations in the first place. For example, you might also like X because you watched Y, and so on. A balance between such explainability and annoyance requires to be creative. In this slide, the two pictures on the top are the real products which demonstrate the explainability of AI content in a way that is user-friendly and not intrusive. However, if you see the two images below, they explain the AI decisions using highly technical demonstrations, which, even though useful, might not help every user in general. For example, the image in the fourth quadrant gives a detailed information on what parts of the image contributed to the prediction results. Another thing is that they take up a lot of real estate. Although these are mostly research-based websites meant for technical audiences, and this problem doesn't exist here, but I have put it here just to demonstrate why we need creativity from the designers to follow basic AI principles in design in accordance to uh, effective solutions. For example, let's just say we build a text classifier inside a chatbot which predicts the sentiment of the text. Now, let's say you detect positive sentiment, and it could be annoying to give the user an explanation like your statement is similar to a positive sentiment statement, and hence the result. Even though the explanation could be correct, it may be annoying. Instead, a simple UI which can slightly highlight the positive words due to which the sentiment seems positive could be informative as well as less annoying for the user. Hence, the idea here is to get creative and decide on case by case basis about the principle of explainability and user experience without trying to follow similar suggestions that may not be useful in particular scenarios. So, we know now how AI works on a basic level, and the importance of data seems very clear. Hence, data acquisition strategy is quite crucial to build an AI solution. Data can be collected from the users inside the product in terms of user feedbacks, or can be collected through other channels as well. Enabling the users to accept or reject AI content could also be a part of data acquisition strategy. Potential designs which can automatically generate any kind of possible training data passively when the user interacts with the UI can be a possible first step. So a few examples here are from Google News, Amazon, Replica AI demonstrate how the user feedback integration could help with data acquisition in order to improve the situation. Also keep in mind to notify the users about the changes over time. For example, what do the users mostly talk about as the first statement in a chatbot, and how can we move the conversation in the right direction automatically using an AI component? one decision to focus on. Now, this may not have an initial model which is AI based, but over a period of time, it can be enhanced using AI. So there are a lot of other creative ways to collect data. So one of the brilliant ways was used by Google as reCAPTCHA, which we still use to this day, and it keeps getting innovative. And there are other ways that have been kind of put there on internet, like for example the social media campaign, uh, the 10 years challenge by Facebook, etc., etc. There are a lot of gaming apps that also try to collect and uh, train supervised models. There's a lot of possibilities in getting creative here to collect data. But keep in mind that such data being collected from the interface could also be polluted to some extent. For example, a user might mistakenly or deliberately select a wrong option. Hence, a mitigation strategy is also required in these scenarios. Now, with the power also comes responsibility, as the famous saying goes. The data drives the complete solution and thus needs a lot of care and considerations when used to train a model. One of the most notable issues that has been highlighted by different communities is the bias in the data collected. There are a lot of examples when a model prediction was wrong due to bias in the collected data. For example, Google Images algorithm tagged a photo of a black woman as an animal. There are a lot of cases of distributional unfairness, ossification, biasness that have come into light after the data being used is either biased or incomplete in some way. One way to mitigate the risk of such instances is to test extensively and as many weird scenarios and edge cases as possible, and think about the design which can ensure that any scenario does not become obviously biased against the users. Another better way is to probably have a diverse team and have a strategy of diversity and inclusion in place to mitigate this risk with the team which is handling the data. A famous method for testing the AI solutions is Wizard of OS testing. I don't know if anyone has heard, but it also it's used extensively in conversational bots testing. Usually, both these, like a lot of steps like testing different kinds of ways and different kinds of solutions would be considered when designing a AI solution. So AI solution most of the times are a cyclical process of making the product better, getting more users, and then more feedbacks, and again making the product better, and this continues. So also feedbacks must be non-intrusive and should not block the users and must be optional. You don't want the users to feel that they are doing free labor for you by giving you required feedbacks. The key takeaway is that user feedbacks can help engineers collect training data to make the algorithms work even better. We had visited ethics earlier, and here is one of the most important aspects of ethics that needs to be discussed. One needs to be very careful about the data that is being collected, as most of the countries are now introducing data regulations to minimize the data privacy issues and also introduce processes which boost data transparency, most notably GDPR. The data must be collected with user consent, specifically if it contains user information, which can be personally identifiable. Moreover, data security needs to be also considered. This again needs a lot of collaboration between the tech team, regulatory teams, designers, legal, and if not properly considered, it can prove to be an expensive mistake. A quick search on this topic on Google shows increasing numbers of lawsuits concerning data and AI related issues. Also, the data collection must be organized properly and should be appropriately structured to be helpful for the developers. Hence, it is important to understand the details around data collection and storage while designing such an interface for user experience. Now, as things are becoming a bit serious, let's now move on to the next part of the design. So now that we have covered most of the design principles for designing AI solutions, why do we need creativity at the core of the complete process? This is because AI brings a lot of responsibility and the real estate for design is very limited. Hence, it becomes tricky to balance the interaction, prevent overload of information, and yet communicate properly to build trust with the users without annoying the users and with repetitive or too much information. Sometimes it may seem that the design principles go in opposite directions with each other, and hence it may it becomes a playground for creativity to align the required aspects for a greater user experience. I hope the discussion so far also clears the air around why design is such a crucial step in developing an AI solution. To summarize and wrap up our discussion, I would like to present the UX design framework, which has been released by Microsoft. It can be considered as a structural framework to use in general and is a well researched one. This applies to the designers as well as the developers and AI engineers. When starting to develop an AI solution initially, one needs to make clear what the system can do and make clear how well the system can do what it can do. This includes things like how often the AI system may make mistakes. Once the initial phase is completed, the interaction decisions should be based on these factors. Time services based on context, which basically means time when to act or interrupt based on the user's current task and environment. Show contextually relevant information, match relevant social norms, which means ensuring the experience is delivered in a way that users would expect, given their social and cultural context. Mitigate social biases, which means ensuring that the AI system's language and behaviors do not reinforce undesirable and unfair stereotypes and biases. If something goes wrong, support efficient invocation, which means make it easy to invoke or request the AI system services when needed. Support efficient dismissal, which means make it easy to dismiss or ignore undesired AI system services. Support efficient correction, which means make it easy to edit, refine, or recover when the AI system is wrong. Scope services when in doubt, which means engage in disambiguation or gracefully degrade the AI system services when uncertain about a user's goal. Make clear why the system did what it did. To improve the AI system over a period of time, remember the recent interactions, that is maintain short-term memory and allow the user to take efficient references to the memory. Learn from user behavior, that is personalize the user's experience by learning from their actions over time. Update and adapt cautiously, that is limit disruptive changes when updating and adapting an AI system's behavior. Encourage granular feedback, that is enable the user to provide feedback indicating their preferences using regular interaction with the AI system. Convey the consequences of user actions, that is immediately that is immediately updated, or convey how user actions will impact the future behaviors of the AI system. Provide global controls, that is allow the users to globally customize what the AI system monitors and how it behaves. Notify the users about changes, that is inform the user when the AI system adds or updates its capabilities. Finally, I would like to mention the famous quote by Sir Isaac Newton. If I have seen further, it is by standing upon the shoulders of the giants. The credits goes to the creators, compilers of the images and content being used to demonstrate the design principles here, which I could use in addition to what I already know. And we are hiring for multiple positions. Please apply on our website and reach out to me if you would like to. There's another news since I submitted this talk, and that is that our company Pecan has been acquired by Workday, which is very exciting for us as well. So I'm looking forward to more applications. And any questions, please? Yeah,
That's fantastic. And congrats on the acquisition. That's very exciting.
thank you.
I loved those guidelines that you shared at the end. I can see easily how they relate to AI, but also to just software development in general. The one that stuck out to me was make it clear why the system did what it did, which I think is something that we frequently forget about as engineers. But then all of a sudden, when you're in that place where you need to justify a decision or be able to backtrack on it, there's really nothing more important. I have a question to kick things off. I know I hear a lot from other software engineers who want to get into AI. They have this interest in the subject matter, but aren't really sure how to get started. Do you have any advice for anyone in the audience who might be in that boat?
Okay, so AI is quite a very generic field. I would suggest to start with uh, trying to narrow down the fields that you want to be in. So there are different kinds of areas like whether you want it to be computer vision, NLP, or gaming, or any other. You have to choose, and to try it out, I would suggest to kind of, there's so many material available online, and it will be great if you can go through Kaggle or some other projects, some personal projects, and just look for how can you implement AI in your own solutions on what you're building, and take it from there. So I think that could be a good starting point for someone who wants to enter into the field.
Makes sense. So narrow it down and then find ways to implement it in your own projects so that you're not starting from scratch if and when you are able to work on it.
Yeah.
Very cool. There was a question earlier, which I think we might have answered, but from Rasma about data acquisition. So does data acquisition happen even if a user has a non-AI component?
Definitely. So there are a lot of cases when we start building AI solutions in the longer roadmap, but we don't implement it in the short term because we don't have enough data. So a lot of cases, so for example, let's say some passive responses, some like clicks, things like this. These all adds up to kind of collecting data in non-intrusive ways and using it for some sort of supervised learning. So definitely it can be collected with non-AI components. In fact, I would recommend to start with non-AI components.
Right, from your point that you might not have it in place right now, but it's likely that any information you can gather now is worth gold to you in the future when you do have the AI components to layer on top of it.
And this is why design comes into picture. Like, can you design the things that you want to collect in a way that it's it's not intrusive, and you can get maximum data possible.
Got it. Makes sense. Well, I think that's it for questions. So Jyoti, thank you so much for all of this. I think it was fascinating. Thank you to everyone who attended. We were so happy to see you here. We encourage you to go and check out all of the other sessions we have going on today. The next round will be starting in approximately 7 minutes. Also check out the networking where you can go and be linked with someone else one-on-one for a short conversation. It's a great way to grow your network. Continue to enjoy the conference. I have a workshop tomorrow if you need a recommendation, so come and join me for that. And everyone have an awesome rest of your day. Thank you once again for joining.
Thank you.
Bye, everyone.
Yeah, bye.